It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
Yeah. Good evening, everyone. Welcome to Unacademy, India's largest e-learning platform, which is acting like a bridge between the dreams and success stories of many students across in India in different parts of education system. You may call it as you can take it as a competitive exams for engineerings, or you can consider exams for medical field. We can consider the IIT entrance examinations, JEE entrance examination, NEET examinations, UGC NET examinations, whatnot. Unacademy is standing with the students who are in the corners of the country, who wants to learn, who are desired to get success, right? So you're all very lucky to be part of here. You're very lucky to be part of here. Please welcome. Yeah, welcome. So today we are going to discuss again a subject called electronic devices. Electronic devices, which is one of the important subject of the gate examination, or gate and ESE, whichever you take, gate and ESE. So for both this Unacademy electronic devices is very important. Electronic devices is very important. It's going to be lecture number 19, which we are going to discuss about diode capacitances. Diode capacitances. Good evening, Vasu. Good evening. Welcome. Yeah. So myself, Shravan Kumar, having master's degree from JNTUH in VLSI system design. And I have 10 plus years of teaching experience, and the subjects which I am handling is EDC, which I am handling right now on YouTube classes, YouTube live classes, which I am taking right now. And analog electronics is what I am taking. Almost many parts of analog electronics which I have discussed are on Unacademy app. So, and one more thing which we are planning is we want to have a different course on analog electronics. So a full-fledged course on analog electronics is going to be launched. We are thinking in those lines that we want to have this do some analog electronic course as early as possible. And we have another subject called digital EMFT. I will come back to this digital MFT once we finish this EDC and analog. So my code is going to be SVS10, that is the referral code, which will be used to get 10% discount on Unacademy Plus subscription. On Unacademy Plus subscription. On Unacademy Plus subscription. So what is the use of having Plus subscription? What is the use of having Plus subscription? You will have live classes. You will have live classes. You will have crash courses. And then you will have a weekly test. You will have a weekly test. And you will have a doubt solving session. So this is very important. Every fourth hour is going to be a doubt solving session. Every fourth hour is going to be a doubt solving session. And the sessions will be in English and Hindi. So those who are from North India, Hindi belt, they can listen to this Hindi, and all South Indians can listen in English also. It is very much advantageous, And you have something called rank improvement batch. So this rank improvement batch is useful for those students who are having some strong foundation and those who want to improve their rank. So this is RIB, that is a rank improvement batch, right? So along with this, the iconic batch, if you go for iconic batch, you'll get a personal coach. You'll get a personal coach, which is very important. So, the personal coach will guide you in the preparation strategy. And you have something called study planner. The customized study planner will be available. And you'll have a study booster sessions. So you'll get essential guidelines from and regular workshops. Regular workshops will be conducted how to improve your study sessions. And you'll have something called personalized test analysis. So you'll get an in-depth analysis for the test by the different types of sections and questions type. This is very important. And along with this, you'll have something called preparatory study material will be available. Good evening, Balaji. That's good that you have finished all the previous classes. I'm very happy about it. That's great. With lot of great speed you have finished. Right? So if you have some doubts, you can ask me, or you can comment on the video. Okay, so that I may answer the questions. Is that clear? Okay, that's good. I'm happy about it. So plus subscription will be for 12 months, 18 months and 24 months. Plus subscription will be for 12 months, 18 months and 24 months. So you will have different fee structures. For this is going to be 22,225 rupees, maybe increased also right now. So this is going to be 34,650. Maybe there will be slight increase in the fees also. And this is going to be 39,600, which is also increased. And SVS 10 is a promo code. SVS 10. So Vasu and Balaji, are you from which engineering college? You are from which engineering college? I think I heard that you told me that you are studying second year engineering. From which college you are studying? Are you from same colleges? Okay. So SVS 10 is going to be the code. SVS 10 is going to be promo code. So that you will get 10% discount on. So that's great, Balaji. University College. Seriously, that's great. Yeah. So did you like all the sessions? Of my classes? Yeah. This is all about plus. And you have something called iconic. For iconic, you have 12 months and 24 months. So your fee structure will be 45,225 rupees, and for 24 months it will be 66,600 rupees. So you have a SVS 10 as a promo code, that is 10% off again, and 10% off on your uh, fee structure, whatever fee structure. Was he also from university? Oh, that's great. That's great. That's great, Vatsu. That's great, Vatsu. That's great, Vatsu. So that's great. That's great. Hope you're happy with my teaching. I'll be energized by looking at all your names, and that too, you are in second year. I could find lot of energy from you. If you are in second year and still want to learn a lot from this today, that's really great. It should be appreciable. Your effort should be appreciable. Your effort should be appreciable. Thank you, Balaji. Thank you. Thank you. Yeah, you can pay this fees using EMIs. You can use the EMIs, and you can use some credit cards. Some credit cards. You can use wallets. So whatever you want, you can do all these things. Whatever you can do. Yeah. And somebody who did not download Unacademy app, we would request you to download the Unacademy app, so that you can listen to, you can follow me on other areas also, other subjects also, right? So we are calling something called in step one. In step one, you just go to Play Store and type Unacademy Learning App. You'll get like this. Click on install. So yeah, you install many other Unacademy apps or other apps also. Was you from diploma background? No issue, no issue, no issue, no issue, no issue. Vasu, you are bang on. You're bang on. You will get succeed. You will get succeed. You will not worry. You will not worry. Success is with you. Success is with you. Just we will have one-on-one interaction session one day in coming days. We'll plan one-on-one interactive session. One-on-one interactive session. Okay. That's great. That's great. So step 2 is going to be just install Unacademy app. Step 3 is going to be manage your goals. You have to choose which goal you want to. That's going to be GATE and ESE. GATE and ESE. This is going to be IIT JAM. All other things will also be there. So just ensure that you have selected GATE and ESE. If once you get selected for GATE and ESE, you'll have 3 types of classes. 3 types of classes. One is class plus class. Second one is class free courses, and third one is special classes. This free course and special classes will be free, and plus classes is going to be paid. That I think I have explained you. Mahendra, good evening. Mahendra, good evening, Mahendra. Step 4 is going to be just subscribe and get subscribed, right? Okay. Yeah, this is the new series which was started on December 20th. December 20th, targeting 2022 and 2023. A free special classes started. So which will run for the entire year. This will run for the entire year for 2022-2023. For 2022 and 2023, right? So know your basics. Know your basics, right? So who will be guiding? India's top educators will be guiding across all the branches, right? So subject-wise strategy to crack GATE 2022 and 2023. 2022-2023. The complete roadmap to approach each subject of every branch. Each subject of the every branch. So what do you mean by every branch? We have mechanical, civil, electrical, ECE, CSCIT, and chemical engineering. Chemical engineering. All these subjects you have. All these for all these branches you have this one. This is ASCENT 2023 is targeting 2023 students for electrical and ECE students. Electrical and ECE students. Which started on 21st of December. Which was started on 21st of December. So the subject will be in English and Hindi. Subject will be in English and Hindi. This is again 2023. So if you want to join here, so you can use this code ECE GATE 10 for ECE students, and ECE doubly GATE 10 for W students, and you will be guided by top educators of Unacademy. Top educators of Unacademy. Top educators of Unacademy. Okay. And next you have Evolve. You have Evolve GATE 2022. So targeting 2022 GATE, we have something called Evolve. So which is also started on 21st of December. 21st of December. It will be in English and in Hindi again. So you should use same code. For evolve also you'll have same code. So it's also started on 21st, and it will be again in English and Hindi. It will be again in English and Hindi. How to access? It is all free. It's all free. Are you on an Unacademy app? Unacademy app? Go and search for Know Your Basics. There will be a series by name Know Your Basics. There will be a series by name Know Your Basics. Search on Know Your Basics. Simply you'll get it. Simply you'll get it, Balaji. Simply you'll get it. Okay. Yeah. We'll move on. And this is Combat, Unacademy Combat. This is a test, online test, which will be conducted. You'll have a lot of fun while you are doing this test. And use this code SBS10 to unlock. And it is tomorrow from 6 p.m. At tomorrow 6 p.m. you have. So you have exciting prizes. We have exciting prizes by Unacademy. So for 3 months free subscription is also a great thing. Almost you'll get a very good amount. And GATE and ESE subscription for equivalent Amazon voucher. So if you want an Amazon equivalent voucher, you'll get an Amazon equivalent voucher. From 4th to 5th, you'll get 500 rupees simple voucher. Okay. And this is what last time happened. The students who got first prize won MacBook Air. You can see the civil engineers Shalini, and electrical Isha, and mechanical Sandeep. The second prize was a Apple iPod Mini. So civil students win that Satyam Kesri. Electrical is Ankit Gupta, and mechanical was Joy Chavda. Right? And civil is you will get AirPods. Still you will get AirPods. Sir, have fun. Good evening, Krishnaveni. Good evening. Welcome. Good evening, Krishnaveni. Good evening. Welcome. So this is what you will have. So all these, Krishnaveni, I think you missed all my classes, the problems. Just as you asked, we have discussed almost 4 hours, 3.5 to 4 hours on problems. So you missed a live problem discussion. You missed a live problem discussion. You missed my live problem discussion. Acha, okay. No issue, Krishnaveni, no issues. You can cover this. You can cover them now. Right? Don't miss the classes now on. Don't miss the classes now on. Okay? That's great. Yeah. Now all you can follow me on Unacademy. I think you are getting my notes on Telegram channel. So just follow me on Unacademy. Next. So today the topic is going to be, in the last classes what we discussed is, we all discussed in the previous classes all the problems based on PN junction diode. Very good problems we have discussed. Very good problem discussed. Now we will discuss about diode capacitances. This is also a very important topic. Diode capacitances is a very good topic. The diode capacitance is going to be very good topic. So, before we discuss about diode capacitances, so we need to understand something called how a PN junction diode can be constructed. How a PN junction diode can be constructed. So this capacitance is a word which we will do. We will come back to this complete what do you mean by diode capacitances. So before that diode capacitance, simply it's like that capacitance which exists in a diode is nothing but diode capacitance, right? So you have 3 different modes of operations in a diode. You will have equilibrium position. You will have a forward bias, you have reverse bias. For all these 3 different conditions, so what would be the capacitance present in the diode? Capacitance present in the diode, we will see. Okay. So the PN junction diode construct. Now we will see how can a PN junction diode can be constructed. In how many ways it can be constructed. So a junction can be constructed by using different methods, right? The different construction types of PN junctions are alloy or step graded junction, grown or linearly graded junction, and you have something called diffuse junction. Yeah, diffuse junction. You have something called diffuse junction. Now we'll see about each one of them briefly, and then we'll move on to the original topic of diode capacitances. Okay. Now if you see, so what do you mean by alloy or step graded junction? So a step graded junction is a junction in which there is an abrupt change from the acceptor ions on one side to the donor ions on the other side. So what he's saying is, a step graded junction in this area. So this is like this. If this is a P type, this is a N type. So if you see the concentration, so if you'll find a sudden jump, so this area is going to be acceptor ions, acceptors, and then this is going to be what, sir? This is going to be donors. You can see here, so there is a sudden change. Yes or no? Sudden change. Till this point, let's say this is going to be x is equal to 0. Till the x is equal to 0, you have acceptors. Suddenly after x is equal to 0, you have donors. So it is a step grade, suddenly increase. The gradient of the acceptors and donors is suddenly changed. So because of that, it is called step graded junction. You can find a step kind of this thing, yes or no? So from here to here suddenly change, or here to here suddenly change. From here to here suddenly change. So there is a step change. Right? It's this step change. Right? Let's say this is going to be minus QNA. This is QND. Charge density I'm talking about. So suddenly changes from minus QNA to QND. So this is called a step graded junction. Such a junction is formed by placing indium pallet against N-type germanium wafer and heating this assembly to a high temperature for a short time. What is saying, sir? So he's saying and a trivalent impurity is placed. on N-type germanium, right? And if you increase it to a temperature for a short time, what happens is, as a result of heating, some of the indium dissolves into the germanium to change the germanium from N-type to P-type at a junction. So be clear. So what is saying, sir? Here is, so some material of germanium is taken. On which, so you have put a trivalent impurity. And you are trying to heat it. So once you try to heat it, they form the junction. So some of the trivalent impurities will get into this. Trivalent impurities will be get into this. Okay. So in a short time, what happens is, so some N-type to P-type, they'll convert. Such junction is called alloy junction or fuse junction or step graded junction. Now we have something called grown or linearly graded junction. So if the donor impurities are introduced into one side and the acceptor impurities into other side of this a single crystal from a melt of silicon or germanium, the grown junction of the linearly graded junction will be formed. What does it mean, sir? So the junction will be formed like this. So slowly it is increasing. Linearly. linearly. It's happening linearly happening. Earlier it was sudden change. But here it is changing linearly, slowly. Let's say here 100, it is 90, it is 600, like this. So slowly it is increasing the value of electrons. Here decreasing the value of holes. So this is called step gradient junction. If you want to draw, ideally you can draw like this also, sir. Ideally you can draw like this also. A linearly graded junction. A linearly graded junction will be like this. Right. Next, diffused junction. So in diffusion process, a vapor of semiconductor material is exposed to a gas of impurity material. Then the atoms of the impurity material diffused into the semiconductor to form a diffused p-n junction diode. So here what happens, sir? They have considered a single silicon. And on one side they have poured p-type, trivalent, and other type is n-valent. So the junction is formed. But earlier what happens, sir? On one form of the semiconductor material, the silicon or germanium, other form is placed, other trivalent impurity is placed, and it will be heated. So because of that, so some junction is formed. But here what's happening? We're considering a single crystal. We're considering single crystal, and it was exposed, and it was on one side you are added donor, on the other side you added acceptors and donors. So there forms a junction. So there's another thing called diffusion junction. So what do you mean by diffuse junction? Diffuse junction is nothing but, so you have some p material or n material, whatever. Let's say this is a p material. T material silicon p material. Now what it's saying, sir, is asking us to expose it to the. So this is what happening. Exposing it to the n type gas or n type impurities. What is saying simply? So exposed to a gas impurity of n type. So this is a n type gas impurity. So it is exposed to gas impurities. Now what happens, sir? Now slowly what happens is the same p material, this will be converting p and this will be converting into n. This will be converting into p and this will be converting into n. I mean this p and n. The earlier p was now due to the exposing of gas impurity. The atoms of the impurity material diffuse into the semiconductor. They'll diffuse the semiconductor to form a diffused p-n junction diode. So you have how many types? You have three types of junctions. One is called alloy or separated junction. Second one is called grown or linearly graded. So most of the time we use this word, step graded junction, linearly junction. Rarely we go for this diffuse junction. We don't generally use this diffuse junction. We will more concentrate on this step graded junction and a linear graded junction. Why, sir? It is very easy. Especially this linear graded junction is very easy. So you will be considering same silicon. On one side you acceptors, other side you are pouring donors. So this will become change to p and this will become n. So but here what I have to do, sir? You have to take one type of semiconductor material. You have to place some trivalent impurity here. So after heating process, it will change to a p-n junction diode. Whereas the DDT has to be exposed to a gas. So these are the three different types of junctions which are formed. Three different types of junctions which are formed in a p-n junction constructions. Is the point clear? Hope all the points are clear so far. Yeah. Okay, we'll move on. We'll move on to the topic. Today's topic, diode capacitances. Yeah. So diode capacitance of a junction capacitances are of two types. You have something called transition capacitance and diffusion capacitance. In detail, we'll discuss about transition capacitance and diffusion capacitance. Okay, Krishnaveni, okay, Vasund, okay, Mahindra, very good. So you have a transition capacitance and diffusion capacitances. We'll discuss in detail. Yeah. Before going to discuss about transition capacitances, I want to introduce you what do you mean by a capacitor first. What do you mean by a capacitor? So what is called a capacitor? How the capacitor works? So just we'll try to recall. We will not get into the in detail. But we'll try to recall what do you mean by capacitor? What do you mean by capacitor? So you might be already knowing from your basics. So you might be already knowing. So this is going to be some metal one. Metal plate, actually we call metal plate 1, and this is going to be metal plate 2. You have two metals, and which are separated by a distance d. And this distance is covered by a dielectric constant. We have some dielectric. So now what happens is, when these two plates are separated by a dielectric, now what happens, sir? Because of this, some capacitance exists, some force of attraction will exist. And we call this as a capacitance. So metal one and metal plate. So we are trying to separate. Let's say this pen is nothing but dielectric. You can see here. So what I'm trying to do, sir? So you can see here, what I'm trying to do is, these two are separated by this dielectric. So this one is one metal. Let's say this one is another metal, right? So these are separated by a distance d, and which is used. Sorry, a dielectric metal is used. A dielectric metal is used in between. So this is called a capacitor. And that corresponding energy is going to be, we know that C is equal to epsilon A by D. We already know this. What is this? Units are in farads. What is this? D, sir? D is the distance between the plates. So this is the basics. I'm just trying to cover again. Yeah, we will discuss in detail, Mahendra. Almost you are there. We'll discuss now. Okay. So see the distance between the plates. A is the area of cross section. And what is epsilon? Epsilon is nothing but permittivity. Epsilon is the permittivity. Right? So this is nothing but C is equal to epsilon A by D. Whose units are farads. So now, you can have three types of capacitance. Along with those two, I have another thing. So I can call this as a capacitances. when the diode is when the diode is at equilibrium, sorry, at equilibrium, when the diode is in forward bias state. Third is when the diode is reverse biased. So for all these conditions we have, the diode capacitances. So the three types of diode capacitances we'll discuss. So generally, so this is represented by Cj naught, or we can call it as a junction capacitance. We can call this a junction capacitance as equilibrium. So these are two things. So diffusion capacitance is when this is diffusion capacitance and this is transition capacitance. Diffusion transient capacitance. Now we will discuss in detail. Now consider at equilibrium now. First case, at equilibrium. At equilibrium. Right? First we'll consider at equilibrium. Now, what do you mean by equilibrium? Let me draw the PN junction so that you'll understand better. So don't we are trying to transfer the knowledge which we have as much as we can. We have. We want to transfer all the knowledge which we have to you. The only thing is you circulate this to your friends, ask them to listen, right? So if they are not listening, it's a golden opportunity for them. Sir, we will not get all the live classes again. Very important. Don't forget to like, share and comment. Okay, we will come back. Meanwhile, I have discussed when I was drawing this. I don't want to lose your attention. That is the reason why I was asking all these things. Okay, coming back. Let's say. So here, what will have, sir? Equilibrium. So you'll have negative ions here, negative atoms here, negative ions, and negative ions here. On this side, all positive ions you have. Here, and this width of the depletion is going to be how much, sir? Double is the depletion width, double the depletion width, and this is going to be we know this is going to be x n naught, that is length of the depletion into the end region, and here what you are going to have is going to be xp naught. What is xp naught? Length of diffusion, how much diffusion is diffused into the P region at equilibrium, right? Generally, we say it is going to be minus xp naught generally because it is into minus. So if we consider this is going to be x is equal to 0 here. If we consider this is going to be x is equal to 0, then we call it as the minus xp naught. This is going to be xn naught. It's going to be xp naught and this is xn naught. So is the point clear? So this is what we have discussed earlier. Right? This is at equilibrium. So at equilibrium, what you can see here, you have all the negative charge accumulated on one side, and all the positive charge, all the negative charge is accumulated on one side. This side, let's say this on P side. On P side, all the negative charge accumulated. On inside, all the positive charge is accumulated. Yes or no? On one side, all the positive charge accumulated, right? Now you can see this and this negative charge and positive charge will be repelled. All these positive charge will be repelled. And you see here you will find what, sir? You will find lot of electrons or not, lot of holes or not here. So all these will be accumulated here this point at xp naught all charges will be accumulated on this border xp naught. Similarly here all the electrons will be accumulated on this border. Now what happens, sir? So this region at the point xn naught, it acts like a plate or a separator. Here also again here also this xp naught, at xp naught you can find another separator. So now all these charges from this p region, n region are separated by a distance w. With this, it is anyway, it is not allowing charge carriers to move from one region to other region, right? So can you call it the dielectric? So this region is going to be dielectric, and the charges on p side you have and charges on n side you have. So all this is going to be accumulated here. The negative charge will be accumulated on p side, and the positive charge is going to be accumulated on n side. Okay, negative charge is accumulated on p side, and the positive charge is accumulated on n side. But one thing is sure: at equilibrium, the charge on the negative charge on the p side, that is charge on p side must be equal to charge on inside, because it is equilibrium. We ourselves consider that it is equilibrium. Obviously, when it is in equilibrium, these two charges must be the same. Hi Prashant. Thank you. Hope you are doing good. Yeah, we'll have interactive session later. Okay. Good to see you on YouTube, Prashant. Good to see you on YouTube. Thank you. Okay. So at equilibrium, charge on p side must be equal to charge on n side. So can I say that is q minus must be equal to q plus? Q minus must be equal to q plus. So let's say this would be 1. What is q minus? We know that mod of q minus I'm talking about. Q Na into A into xp naught. Similarly, on q plus, the charge on q plus is going to be what, sir? Q nd A into xn naught. It's going to be xn naught. So from this, what will get cancelled? So you can cancel q and get cancelled. A and A will get cancelled. So what will be remaining? You have Na. You have Na into xp naught is going to be Nd into xn naught. So we know that xp naught by xn naught, whatever you want to write, you can write xn naught by xp naught. Is going to be Na by Nd. This also we have derived earlier. We have also proved that this is what. So assume that this is going to be equation number 2. Xn naught by xp naught is going to be Na by Nd. So now what we know that this total depletion layer width, the depletion layer width W is going to be simply xp naught plus xn naught. xp naught plus xn naught, xp naught plus xn naught. So from this, what is xn naught? From this, what is xn naught? Can I write this as a, so W is going to be, can I write this as a, from this discussion, can write xn naught is going to be NA by ND into xp naught, NA by ND into xp naught, NA by ND into xp naught. So this is going to be NA by ND into xp naught plus xp naught. What we get? The W is going to be, so if you take common, if you take xp naught common, so what will be there, sir? 1 plus, as if you have doubt, I will write like this, NA by ND plus 1. So I can say W is going to be NA plus ND by ND into xp naught. What is going to be xp naught? Xp naught is going to be W into ND by NA plus ND. We have already derived this. We have already derived this earlier also. So xp naught is going to be W into ND by NA. So let's assume this is going to be some equation number 3. Equation number 3. So what is going to be xn naught? Simply xn naught will be same side, Sn naught. So xn naught is going to be what? W into Na by Na plus Nd. Assume this is going to be, as I write similarly. Similarly, xn naught is going to be xn naught is W into Na by Na plus Nd. Xn naught, right? So, but what is C? C, capacitance C is going to be epsilon A by W. So this kind of becomes a junction capacitance. I can call this a junction capacitance. Now from junction capacitance, so the because it's happening at the junction, the capacitance exists because of junction. The junction is not there, no capacitance at all. The junction is not there, no capacitance at all. Right? The junction is not there, no capacitance at all. So the junction capacitance, I can say Cj. Somebody says it's going to be C naught also, sir. What is C naught? C naught stands for, what is C naught stands for? What is C naught stands for? Also, capacitance equilibrium. It's called capacitance at equilibrium. So Cj or C naught is going to be again, I will write epsilon A by W, where W is what? Where W is what? Width of depletion. We know from our previous discussions, we know W is going to be square root of, can somebody remember this? I'll do this. 2 epsilon by Q into 1 by Na plus 1 by Nd into V naught. 2 epsilon by Q into 1 by Na plus 1 by Nd into V naught. 1 by Na into 1 by Nd into V naught. Now simply we'll try to substitute this in the above equation. Now in this equation, let's say 5. This is going to be 6. So substitute 6 in 5. If substitute 6 in 5, to substitute 6 in 5, so what we'll get, sir? Cj is going to be epsilon A by square root of 2 epsilon by Q into 1 by Na plus 1 by Nd into V naught. So this Cj, junction capacitance, is going to be, sir, can I write this is going to be, can I try to rewrite this? I'll try to rewrite this so that you'll have a better idea. So this is going to be A. I'll take it out. So epsilon is there. So can I write the epsilon as the root epsilon into root epsilon? Root epsilon into root epsilon. It's going to be, you're going to have 2 epsilon by q into 1 by Na plus 1 by Nd into V naught. So 1 epsilon, this is going to be cancelled. So 1 epsilon naught and 1 epsilon is going to be cancelled. So I'll try to take out 2 also here. If I try to take out 2, I have to multiply it to multiply with 2. I have to multiply with 2. So what we get here is so Cj is going to be a by 2 square root of a by 2 square root of. Now what happens, sir? This q comes up or not? This 2 also comes up. So what will be remaining is 2 epsilon q, and this is going to be Na Nd by Na plus Nd. So I can write this is going to be Na Nd by Na plus Nd into 1 by V naught into 1 by V naught. This is going to be 1 by V naught. We can also call this as Cj naught. Cj naught at junction at equilibrium. Capacitor junction at equilibrium. Capacitor junction at equilibrium. Okay, this can be written as a by 2 into very simply we have derived this a by 2 into 2 epsilon q into Na Nd by Na plus Nd into 1 by V naught. 1 by V naught. This is one of the most important equation which we require to solve many problems. Many problems. So very important. Cj naught, that is junction capacitance at equilibrium. So it will be a by 2 into square root of 2 epsilon q into Na Nd by Na plus Nd into 1 by V naught. Na Nd by Na plus Nd into V naught. What is this V naught? Where V naught is, what is V naught? We know all everything, sir. We know A is the area of cross section. And epsilon is the permittivity. Q is charge. Na is the acceptor concentration. Nd is donor concentration. V naught is potential at equilibrium, right? Potential barrier value of the potential barrier. So very important. V naught is going to be the potential barrier size. Voltage barrier. Voltage of the potential barrier also you can say. Voltage of the potential barrier voltage. Potential barrier voltage at equilibrium. Voltage at equilibrium. Okay, so this is what very important. Now what it would be when it is forward biased? When it is forward biased, what happens, sir? This V naught will decrease or not? V naught will be decreased. By an amount of applied voltage Vf. By an amount of applied voltage Vf. Vf. That is, this V0 will become V0 minus Vf. V0 minus Vf. V0 minus Vf. So what is this Cj? Again, this becomes Cj at forward biased voltage. The junction capacitance at forward biased. So junction capacitance at forward bias. So forward bias junction capacitance. Forward bias junction capacitance is going to be again A by 2 square root of 2 epsilon q Na Nd by Na plus Nd into 1 minus V0 minus Vf. V0 minus Vf. So if you want to express this Cj in terms of Cj naught, if you want to express this Cj in terms of Cj naught, so simple. What I'll to do, sir? I'll take V0 out here. I'll take V0 out here. I'll take V0 out here. So if I take V0 out here, what happens is, you can see very simple. All these things are very simple. Cj is going to be A by root 2, A by 2 square root of 2 epsilon q Na Nd by, just a minute, Na Nd by Na plus Nd, Na plus Nd. I'm taking what I'm saying, sir. I'm taking V naught out, V naught common. So what will be remaining, sir? This will be 1 by 1 minus Vf by V naught. Vf by V naught. Vf by V naught. Now if you look at here, this complete thing is Cj naught. This complete thing is Cj naught. This is going to be, what is this going to be, sir? Is it not Cj naught? Is it not Cj naught? It is that is junction capacitance at equilibrium. So this junction capacitance, new junction capacitance, I can write it as Cj naught by square root of 1 minus Vf by V naught. Vf by V naught. Vf by V naught. Vf by V naught. So if you want to express this in a different way, I can write Cj is equal to Cj naught by 1 minus Vf by V naught power 1 by 2, I can say. This is very important equation. Very important equation. Many a times in the examination, he will give you the value of Cj naught. You will get the Cj value, Cj naught value. He will ask you to calculate Vf value, V naught value. So for different cases, he will give you different one. For different cases, he will give you different one. For different cases. But there is some note here. So for a step graded PN junction, the Cj is going to be Cj naught by 1 minus Vf by V naught power 1 by 2. But for a linear graded PN junction, Cj, that is junction capacitance Cj is going to be, Cj naught by 1 minus Vf by V naught power 1 by 3. So if you want to summarize, or if you want to make it natural, or if you want to make it common, so commonly Cj is going to be Cj naught by 1 minus Vf by V naught power n, where n is equal to 1 by 2 for step graded, and n is equal to 1 by 3 for linear graded, Such a beautiful this thing, sir. We got many problems based on this. So if possible, today only we'll try to discuss problems based on this from the previous gate problems. Very simple. This is how you should remember. So n is equal to 1 by 2 for step graded, to 1 by 3 for linear graded. Okay, next. We have something called a diffusion capacitance. So this diffusion capacitance occurs. So when will the diffusion occur, sir? Diffusion process occurs when? When will the diffusion occurs? When the diode is forward biased. Diffusion occurs. Are you listening or not? Correct, Vasu. Correct, sir. Correct, Vasu. When the diode is forward biased, diffusion capacitance occurs. Now we'll discuss about diffusion capacitance. So that is the reason why we call it as a diffusion capacitance. We'll represent this with the CD. So what is saying, sir? When the diode is forward biased. When the diode is forward biased. The diode is forward biased. So this can also be called as storage capacitance. Remember, diode diffusion capacitance can also be called as storage capacitance. Okay, Mahindra, very good. Now we know, sir, we will try to do it very simply. We don't do all complicated derivations. We'll do it very simply. We know that the capacitance C is going to be Q by V. Yes or no? So from this we can say Q is equal to CV. So, or we can say C is equal to dq by change in charge by change in voltage, we can also call. So dq by dt, dq by dv. So what is current? Current I, can I say current I going to be dq by dt? Yes or no? This current is going to be dq by dt. So then, from this, can I say dq is equal to I dt. So if integrate on both sides, what will get, sir? You'll get q is equal to I into tau. Where tau is lifetime of the charge carrier. Lifetime of the charge carrier. Right. So now what is here? C is going to be dq by dv. Substitute this C is equal to d by dv of I into tau, d by dv of I into tau. So this is always constant. So I can say C is equal to tau into di by dv, di by dv. C is equal to tau into di by dv. So remember this point. Now we'll move on. Now this is also one of these things you have to remember. Remember this formula also. C is equal to tau into di by dv. C is equal to tau is equal to di by dv. C is equal to tau into di by dv. So so now from diode current equation, 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 we know that I is equal to I naught into e power v by eta vt minus 1. So by neglecting eta vt minus 1, let's neglect this. Let's neglect this minus 1. What we'll get is, sir, I is equal to I naught into e power v by eta vt. Let now it's going to be I is equal to I naught into e power v by eta vt. Now substitute this I here. Substitute this I here. So now C is equal to tau into d by dv of this I naught into e power v by eta vt. d by eta vt. So I naught is a constant that we know. So C is equal to tau into I naught into d by dv of e power v by eta vt. So now what is going to be d by dv of e power v? d by dv of e power v. That's going to be obviously it's going to be av, d by dv of av. So C is going to be what we'll get, sir? Tau into I naught into e power x, we'll get e power x, we were saying e power x. So eta vt, and this x is going to be what? You will again a. You'll get that is going to be 1 by eta vt. You'll get 1 by eta vt. So I can write C is equal to tau into I naught into e power v by eta vt by eta vt. Sir, what is this? If you consider this I naught into e power I naught into e power v by et is this not I? Is it not I? So I'll replace this again. C is equal to tau I by eta vt. This is the most important formula. Many times, many problems are asked on this. So I can call this actually CD. I should call this as CD. I think I missed the subscript D. Diffusion capacitance CD. Why CJ naught is calculated for reverse bias? We'll do it now. We'll do it now, Vasu. Do not worry. First, we'll finish off this forward bias and we'll go to the reverse bias. We'll do it, Vasu. We'll do it. Do not worry. So I can call this as CD. All the time you can call CD, then CD. So if I'm missing doing something wrong, so CD you can call CD, diffusion capacitance, CD. This is a normal general. This is not required this thing. If you want, you can write it here also, no problem. CD going to be okay. We'll calculate it. You not worry, Vasu. We'll do it. Okay. So CD is going to be tau I by eta Vt. This is a very important formula, sir. Very, very important formula. CD is equal to CD is equal to C is equal to tau into I by eta Vt. Many problems will be asked based on this. Many problems will be asked based on this. Many problems asked will be asked based on this. Many problems will be asked based on this. Right? Tau I by eta Vt. Tau I by eta Vt. Okay. Now, as per your discussion, as per your requirement, we'll discuss now what is a capacitance when it is reverse bias. Okay. Okay. Now we'll discuss. You need not worry. We'll discuss. Very simple. It's also very simple. Vasu itself very simple. Now we'll see. We'll see. So when reverse biased, no problem. When reverse biased, the capacitance when the reverse bias, when the capacitance exists, we call it as transient capacitance CT. Transient capacitance CT. Okay, we call it as a transition capacitance CT. We call it as a transition capacitance CT. So again CT is going to be again same epsilon A by W only, but W is if you want to write, you can write WR, something like this. So your width of depletion region, when it is reverse bias, width of the depletion region when it is reverse biased. When it is reverse biased. Okay. When it is reverse biased. So what is the W formula? Did you remember? W is going to be. We'll do it. We'll not worry. So 2E epsilon by Q into 1 by NA plus 1 by ND into 1 by, it's going to be V0 plus VR. V0 plus VR. Did you remember? This is going to be V0 plus VR. V0 plus VR. So then it is going to be what? Then it's going to be what? CT is equal to epsilon A by, substitute this now. Very simple. You'll get 2 epsilon by Q into 1 by NA plus, are you listening, Vasu? I'm doing it for your sake. Of course, this will be useful for everyone. You not worry. So it will be 1 by NA plus 1 by ND into 1 by V0 plus VR. V0 plus VR. Oh, no, not here. Sorry. So this is not correct. This is not supposed to be denominator. It's going to be V0 plus VR. I'm sorry. Here V0 plus VR. V0 plus VR. Okay. Now what you can get, sir? Root. So simply we can write CT is equal to A by 2 square root of what you can write, sir? A by 2 into square root of 2Q epsilon into NA ND by Na plus ND into 1 by V naught plus VR. Again, you take V naught out. If you take V naught out, CT is going to be A by 2 into square root of 2Q epsilon into NA by Na plus ND into 1 by V naught. I'll write this as 1 by V naught into 1 by 1 plus VR by V naught. VR by V naught. VR by V naught. Sir, again, what is this, sir? Again, what is this? Again, what is this? So, is it not CJ naught? What is this? Go back and see what is CJ naught. What is CJ naught? Same CJ naught, yes or no? So again it will be. So I'll write here CT is equal to CJ naught by 1 plus VR by V naught power 1 by 2. This is a most important formula for transition capacitance. The capacitance which is existing when it is in reverse bias, we call it as transition capacitance. Transition capacitance. That is correct. That is correct, Mahendra. You are right. You are right. So this is going to be CT is equal to CJ naught by 1 plus VR by V naught power 1 by 2. 1 plus VR by V naught power VR2. Right? So if you want to write it in a different way, you can also write again. So for generalized formula, generalized formula I'll write CT is equal to CJ naught by 1 plus VR by V naught power N, V naught by VR power N. So N is equal to 1 by 2 for step graded, and N is equal to 1 by 3 for linear graded. So transition capacitance. Thank you, Vasu. As you asked, I would explain this CT also. So if you would have not asked, I would have not done this. So thank you for asking this. So yeah, here one important thing you can see here. One important thing here you can see. So as the value of VR is changing, the capacitance is changing. Yes or no? So as junction voltage is changing, as the junction voltage is changing, the capacitance is changing, the capacitance value is changing. Sir, see, I mean to say this is variable. So the capacitance of the junction, PN junction, the capacitance of the PN junction is variable. Is a variable. By changing its voltage and its capacitance is changing. So can I say this can be called as variable capacitor? variable capacitor, variable capacitor. And what does this means? This will lead something to varactor. Varactor diode. Varactor diode. So the concept of varactor diode is nothing but its capacitance can be variable. Its capacitance can be variable. So how it looks like, sir? So very simple, sir. Varactor diode will be like this. So this shows that a a capacitance of the diode is variable. So the symbol of this varactor diode is going to be what this? The symbol of the varactor diode is going to be this. Okay. Okay. Is the point clear? Is the point clear? Okay, then we'll move on. Yeah. So we have the problem now. Can you please answer this question? Can you please answer this question? The diffusion capacitance of PN junction, the diffusion capacitance of PN junction decreases with increase in current and increasing temperature. Decreases with decreasing current and increasing temperature. Increases with increasing current and increasing temperature. Doesn't depend on current and temperature. Doesn't depend on current and temperature. Just think about it, sir. Think about it. Answer the question. Krishnavani said B and Vasu said B. Mahendra, that is for reverse bias only, na? This director will happen only for reverse bias. In the forward bias, what happens, sir? In the forward bias, the D disappears, right? You will not find the D. Just a second. Just a second, 1 minute. Yeah. This is all talking about in reverse bias. Okay. So we'll talk about this question now. The diffusion capacitance of a PN junction. So what is the formula for diffusion capacitance? CD is equal to tau into I by eta Vt. What is this Vt? Is talking about some current and temperature. Current and temperature. Can I write this as C is equal to tau I by eta into T by 11,600. So it means CD is directly proportional to I and indirectly proportional to temperature. Indirectly proportional to temperature. So as I increases, CD increases. As the T increases, CD decreases. Okay. So first is decreases with increasing current. Oh. It decreases with increasing current. No, this is wrong, right? Decreases with increasing current. So as increases, so this is wrong statement. And increase temperature. As temperature increases, C decreases. This statement is correct. This statement is correct, but this is wrong. This is wrong. So this answer is wrong. Decreases with decreasing current. So as the current decreases, C decreases, correct. The answer is correct. So as temperature increases, decreases. As the temperature increases, it decreases. Yeah, this is also right. This is also right. This is also right. Correct, Amanda, correct. But we'll also see this C. Sometimes what happens, sir, in rare cases, answers will be two. Two answers will be given. Very rare cases. Of course, you will mention. Of course, you will mention. You need not worry. Right? So now we'll see this increase with increasing current. Yes, this is right. Right statement. And increases with increasing temperature. This is wrong. This is wrong. Doesn't depend on current. No. Why it is not dependent, sir? It is obviously it is dependent on these values. So the answer is B. Answer is B. This is the right answer. Answer is B. Very good. Good going. Good going. Next. Next we will see. In a junction diode, is asking the depletion capacitance increases with increasing the reverse bias. The depletion capacitance decreases with increase in reverse bias. The depletion capacitance increases with increase in forward bias. The depletion capacitance is much higher than the depletion capacitance when it is forward bias. What would be the answer? Think and tell me. Again, same formula. Same formula. So the in a junction diode, I'll write the answer. As you know the answer. The depletion capacity increases with increase in reverse bias. See, depletion capacitance is CD is going to be tau by eta Vt. Eta Vt. So slowly now, let's say this is going to be reverse bias. This is, of course, I'm calling this as CT. Right? Transmission capacitance. Now this is happening in reverse bias. In the reverse bias is happening. What is happening to this CT? Transmission capacitance. What's happening to transmission capacitance? As this VR is increasing, so CT is decreasing. The depletion capacitance increases with increasing reverse bias. Is it happens? No. When it is increasing, it decreases. Depletion capacitance decreases with increasing reverse bias. I did not say this is diffusion capacitance. So the word is depletion, not diffusion. Depletion, I can call both CT and CD are depletion capacitances. I can call because it happens at depletion region. I have given some other name as CT. That is transition capacitance I have given. So the depletion capacitance decreases with increasing reverse bias. Krishnaveni and all of you have answered wrongly. Again, answer is B only. Okay. We'll go to the next problem. Now you see this. What is saying? A small signal capacitance of an abrupt P plus N junction is 1 nanofarad per centimeter square at zero bias. If the built-in voltage is 1 volt, the capacitance at the reverse bias voltage of 99 volts. So first understand the problem. A small signal capacitance of an abrupt P plus N junction is 1 nanofarad. 1 nanofarad. At zero bias. So understand the word zero bias. Zero bias means equilibrium. So he's saying the junction capacitance Cj naught is going to be 1 nanofarads per centimeter square he has given. Per centimeter square means it is going to be Cj naught by A, because the centimeter square stands for area. Centimeter square stands for area. Okay. If the built-in voltage is 1 volt, that is V0, it is talking V0. Built-in voltage is going to be V0, is going to be 1 volt. The capacitance now, what it would be, what is Cj for VR is going to be 99. VR is going to be 99. Find out, sir. Is it difficult? No, sir. Direct formula only. So what we have? Cj is going to be Cj naught by 1 plus VR by V naught power 1 by 2. Did he mention? No, he did not mention anything, right? So when it is not mentioned, assume that it is going to be 1 by 2. It will be 1 by 2. So how much is this, sir? 1 nanofarads per centimeter square by 1 plus 19. What is V naught? V naught is going to be 1 power 1 by 2. Very simple. Very simple. So Cj is going to be new Cj is 1 by a nano centimeter square by 1 plus 100. Sorry, 1 plus 99. Sorry. I'll directly write square root of 100. So Cj is going to be 1 by 10 nanofarads per centimeter. So always it's going to be Cj is going to be A by A, because he's asking about something. This is going to be Cj by A. This will be 0.1 nanofarads per centimeter square is the answer. 0.1 nanofarad. So 0.1 nanofarad is asking is 0.1 nanofarads per centimeter square. It will be 0.1. So if he is not asking, it will be like nanofarads per centimeter square. Nanofarads per centimeter square. Is the point clear? So Cj by A is going to be, this is going to be the answer. Answer is again B. Why all B's are coming as an answer? B series is going up. B series is going up. Generally, when you are writing MCET examinations, in the MCET and local MCET or some examinations, some student used to put all A's. Some student used to put all A's, some student put all B's, some student put all C's, some student put all D's. Those who have answered all A's, all B's, all C's, all D's, sometimes may used to get some good rank, you know. Sometimes they used to get some good rank. But it not happens with this gate. Don't think that the gate is like this, because gate has negative answering. Negative mark system is there in gate. Negative mark system is there in the gate. So if you answer wrong, so you'll get definitely minus marks. You'll get minus marks. Yes or no? So that system is not there in gate. That system is not there in gate. Luckily, that system is not there in the gate. Right? Right? If that is the case, everyone used to put some ABCDs or some used to get qualify the gate examination. Yes or no? It is easy to qualify gate examination. Yes or no? It is easy to qualify gate examination if you do like that. Huh? But the pattern is different. Luckily, the pattern of the gate examination is different. Okay. Now we'll move to the next topic. Next problem. So consider the abrupt PN junction. Let VBI be the built-in potential of this junction and VR be the applied reverse bias. If the junction capacitance CJ is 1 picofarad for VBA plus VR is equal to 1 volt, then for VBA plus VR is going to be 4 volts. So CJ will be same formula. What we know, CJ is going to be CJ naught by 1 plus VR by V naught power 1 by 2. So you can still write CJ by square root of V naught into V naught plus VR power 1 by 2. So he's saying for let's say CJ1 is going to be for how much he has given? CJ1 is going to be 1 picofarad. It's going to be 1 picofarad. It's going to be 1 picofarad for VBI plus VR is going to be 1. So what is asking, what is CJ2 for VBI plus VR is equal to 4. Very simple, very simple. CJ1 by, so we need CJ2, right? Like write CJ2. CJ2 by CJ1 is going to be square root of, it should be 1 by 4 directly. Into CJ naught. Right? So CJ1 is going to be this. So what we'll get, sir? CJ2 is going to be CJ1 by 1 by 2. That's going to be how much? CJ1 is going to be 1 picofarad. 1 picofarad into 1 by 2 is going to be 0.5 picofarads. 0.5 picofarads. Sir, are you not doing the problems? Are you not doing the problems? Is it not interesting? Is doing problems not interesting? Are you not happy? Correct. Krishnaveni, you have done a good job. Krishnaveni, you have done a good job. Good job, Krishnaveni. Good job. Very nice. Then, Vasu, why you did not do the problem then? Why did not do the problem then? Just listening? Okay, no problem. So if that is the case, you do this problem. Now you do this problem and answer the question. Answer this question, sir. Let me know what is this answer. I'll give you 2 minutes of time. Let's say 2 or 3 minutes to take, whatever time you want to, you can take, and tell me what is this answer. I'll give you 2 minutes of time. Build potential of upload PN junction 0.75 if the junction capacitance CJ at the reverse bias of 1.25 is 1 picofarad. A value of CJ in picofarads when VR is going to be so he has given V0. V0 is going to be 0.75 volts. And VR is going to be 1.25 volts, and its corresponding CJ is going to be 5 picofarads. And if VR is going to be 7.25 volts, let's say this is going to be CJ1, CJ2. Do it on your own. Tell me, sir. Same problem. So again, V0 will not change, right? V0 will not change. V0 is going to be again 0.75 only. 0.75 only. So you have to find out CJ2. Find out CJ2. Find out CJ2. Find out CJ2. Is it difficult? Is it difficult, sir? Same formula. Apply same formula. Apply same formula. And let me know the answer. Let me know the answer. Very simple. Very simple. 2.5 picofarads. Correct. Krishnaveni, correct. Krishnaveni, right. Krishnaveni, you're right. You're right. Vasu. Hope Vasu will also get the same answer. Okay. Okay, Vasu, we'll move on. We'll do the next problem. You go to the next problem. Calculate the barrier capacitance of a germanium PN junction whose area is 1 millimeters by 1 millimeter and whose space charge thickness is 2 into 10 to the power of minus 4 centimeters. The dielectric constant of germanium is going to be 16. What is asking? Is asking CJ. He's going to be asking C. Only asking C. What he has given? Area is given. Area is going to be 1 millimeter by 1 millimeter. Okay. Correct, Vasu. You got the same answer. Good. Now we will try to do this problem. This is going to be 1 millimeter by 1 millimeter. See what is given? Space charge thickness. Acha, okay. What is space charge thickness? Is going to be W. Is given 2 into 10 to the power of minus 4 centimeters. And it is also given something called E is equal to ER is given. Relative free space 16. So what is going to be E? Is going to be E naught into ER. It's going to be 16 into 8.85 into 10 to the power of minus 14. 10 to the power of minus 14. This need to be This need to be remembered. Right? What is asking to calculate C, very C easy, very easily. C is very easy. C is going to be 16 into 8.85 into 10 to the power of minus 14. A is 1 into millimeter, 10 to the power of minus 3 into 10 to the power of minus 3 by epsilon A by this is going to be what? 2 into 10 to the power of minus 4 centimeters. 2 into 10 to the power of minus 4, 10 to the power of minus 2. Why am I changing it, sir? 10 to the power of minus 12. No, it is 8.85 into 10 to the power of minus 14 only. Minus 14. Minus 12. No, it's minus 14. It's 8.85. Here I'm going to do 8.85 into 10 to the power of minus 14 farads per centimeter. So I'm changing everything. Now you do it, sir. Can you do it quickly and let me know the answer? Simplification. Only simplification is left. Simplification is left. So if you see, first let us simplify all these powers. 10 to the power of minus 3, 10 to the power of minus 3, 10 to the power of minus 4, everything will be so simple get answer. Wow, this is right. Oh, this I didn't expect this. So C is going to be 16 by 2 into 8.85 into 10 to the power of minus 14 to the power of minus 14. Minus 14. So C is going to be 8 into 8.85 into 10 to the power of minus 14. So you'll get how much? How much you get it, sir? I think something went 70.8 into 10 to the power of minus 14 farads. This is what we'll get it. Actually, you'll have another centimeter here. Actually, this is a centimeter. If you multiply it, what you'll get is going to be 1 by 10 to the power of minus 12. You'll get actually. This is 8.85 10 to the power of minus 14 per centimeter, right? This is going to be per centimeter. Per centimeter, I missed it. So it's going to be 10 to the power of minus 2 here. 10 to the power of minus 2 here. This is going to be 10 to the power of minus 2 here. I forgot to do that. 70.8 into 10 to the power of minus 12 farads. So can I write this minus 12 as 70.8 picofarads? Vasu, your calculations are absolutely true. This by centimeter I forgot. Because so ER is going to be 8.85 into 10 to the power of minus 14 farads per centimeter. I forgot to convert this into meters. Now I converted. So what we'll get is 70.84 picofarads. You are right from your side. I would have changed the value. Correct, correct only. Correct only. We will express it into picofarads. We'll express them into picofarads. We'll express them into picofarads. Correct value only. Right, right. We'll move on. We'll discuss the next problem. A given forward bias silicon diode with 1 milliamp, what is the diffusion? What is the diffusion capacitance CD1 is equal to with this? I think this is with the diffusion capacitance. With the diffusion capacitance CD is equal to 1 microfarads. What is the diffusion length LP? Assume that the doping of P side is much greater than that of N side. Much greater than that of N side. Much greater than that of N side. So is given I is equal to 1 milliamp. 1 milliamp. CD is going to be 1 microfarads. 1 microfarad. CD is going to be 1 microfarad. So he is asking us to calculate for LP, length of diffusion. How will you calculate the length of diffusion formula, sir? Very strange he is asking, right? Length of diffusion. So what you know, length of diffusion on P side is going to be dP by tau P. This is the formula which we know. dP is a constant we can calculate. dP is a constant we can assume. This is as it is silicon. As it is silicon, dP is going to be simply actually a 13 centimeter square per second actually. No problem. This is the standard value. The standard value. So, but we need to calculate tau P. So, if we can calculate tau P value, we can calculate LP. We can calculate LP. So, but we know CD. So, we know CD is going to be. What is the formula for CD? Is not tau P into I by Vt. We're going to derive Vt actually. So from this we calculate tau P. Tau P is going to be CD Vt into I. So this is going to be what, sir? CD is going to be 1 microfarad, 1 into 10 to the power of minus 6. It's going to be 26 into 10 to the power of minus 3 to current 1 into 10 to the power of minus 3. So minus 3, minus 3, minus 6, minus 12. 26 picoseconds actually. This is by, right? Sorry. So tau P is going to be 26 microseconds. 26 microseconds. 26 microseconds is what tau P is. So now what is asking for LP. Okay, LP. Length of diffusion LP is going to be square root of, so 13 centimeters square, 13 centimeters square per second into 26 to 10 to the power of minus 6 seconds. So seconds will get cancelled. So LP is equal to square root of 13 into 2 into centimeter into 10 to the power of minus 3. So what you'll get, sir? 13 root 2 into 10 to the power of minus 5 to the power of minus 5. This is, I am just converting this. I'm trying to converting this. I'm trying to converting this. So LP is going to be, how much you'll get, sir? Thirteen root 2 into the power of minus 5. Thirteen root 2 is going to be how much? 18.4. 18.4 to 10 to the power of minus 5. So you can write LP is equal to 0.01884 to 10 to the power of minus 2, or I can write LP is going to be 0.0184 centimeters. So that is what the answer, sir. That is what the answer. So we'll move on. We'll move on next topic. Acha, this finishes the diffusion capacitances. This finishes the diffusion capacitances. What is that, sir? Why you did not consider eta equal to silicon? Eta is equal to 2, na? Where, Nana? Did I miss it? The CD is equal to eta Vt. Okay, we consider and do it, Nana. So we consider and do it. No, I might have forgot. I have missed while calculating. You can do it. You can substitute it. No problem. Substitute and find the value. Right? So probably you may get some 13. You may not get this 13. Acha. So you'll get only 13. So if it is going to be 13 microseconds, you'll get, right? 13 microseconds. Eta Vt or 56 or whatever it is. You do it. Okay. You got the new value. Some value you got. Okay, 52 microseconds. Understood, Krishnaveni. Okay, very good. I might have missed it. No problem. So I'll upload these notes. Upload these notes into Unacademy GATE Telugu. Right? Unacademy GATE Telugu. Right? So we have other YouTube channels also. We have these YouTube channels. So Creatrix GATE ESE IN, Unacademy GATE Mechanical Engineering, Production Engineering Sciences, Unacademy GATE Civil Engineering, Engineering Pathshala, Unacademy Computer Science, Unacademy Computer Science you have, Unacademy GATE Questions you have, Unacademy GATE Telugu, right now which we are seeing the live sessions, Okay, and we have electrical junction. In Unacademy Great Telugu, you have other subjects also. You have communication skills subject is going on. Not communication systems. Communication system subject is going on. Aptitude is going on. Math is going on. Some electrical engineering, some power electronics is also going on. So everything is going on. Those who are interested, they can listen to all these classes. So electrical junction is going on, right? Thank you. Thank you. We'll catch up tomorrow. Thank you. We'll catch up tomorrow. Good night for the day. Okay. So don't miss to like, share, subscribe, and press the bell icon. Thank you. Good night. Catch up tomorrow.